slides though?
No, it was who plays Nick Fury?
Who plays what?
Who plays Nick Fury in Marvel, but always like swears constantly?
Is it Samuel L. Jackson?
Yeah, you could buy a clean
Yeah.
pack and a dirty pack.
Oh, I didn't know there was a dirty bag. I thought it just changed the voice.
That's funny. Inappropriate.
Okay. Starting to get a little more into. I feel so bad for him coming in because it's clearly like awkward to walk in the middle of.
Yeah. I don't think he cares about that. I think he's more cares about the fact that he's confused about what's going on. He only misses like 3 minutes.
So that's actually what I was just going to say. I would write these two things down. So yesterday we talked about this. If the derivative is positive, that means the original graph is increasing. If the derivative is negative, that means the original is decreasing. So we're just taking it like another level. So if the derivative switches from negative to positive, that means the original switched from decreasing to increasing. If we go from dec to inc, we get like the bottom of a hill here. We get a relative min. And then the exact opposite there. So write them down and then we'll talk through it. It's not that you guys are going to be gone this hour too. Randy Brown was gone. Trey doesn't exist. So there are going to be like 5 people here. For the mentorship thing, like I know the mentors, you got to like volunteer, right? Like you got to, was there an application process?
Yeah, but
I don't think they like.
It is
there was like a
certified
there was like a survey and like filled out why we wanted to do it, and
They probably took
then they probably
for
just
everyone. What about for the mentees? Every
it's
person?
every person.
So they don't get a choice.
Not really. That's like the BRT. Like they come into the class. I don't know what.
So it'll be like their whole class. Probably. Okay. That's cool.
I think it's cool for people that care. For people that don't, it's gonna be like a waste of time.
Maybe they'll just pick something up. Like
I hope so.
if you're in your little group of 5 and you just don't say anything, you're still kind of there listening. Every little bit of positive influence that gives you your brain is a good thing.
Temperature.
I think it's a cool idea.
I was saying I wish we had it as
Dude,
like
like when you were underclass.
because even when we were just like talking about this, they like gave us questions that they were gonna ask us, like set questions, and we were like saying what we would say to them. And I was like, if someone had told me that,
Right. Like what?
like, how did you prepare for the SAT, or what elective classes should I take, and what elective classes would you recommend? Like,
Yeah,
or it was one was like, how did you like navigating making friends and putting yourself out there?
Just to hear that like other people worry about that also.
Yeah. And then it's like one of the big things is that they shouldn't stress out too much. Like obviously get good grades, but like one B is
Yeah, well, the hard thing was when they're talking about like preparing for the SAT, like my recommendation would have been
Integrated math,
You don't
but now
have
it's
to,
gone. Yeah. Well, no, it's gonna be optional.
Oh, it is.
Yeah.
Okay,
Yeah, it's just not.
It's gonna be like an online. Basically, it's gonna be like the version where you just take a bunch of SATs, do the corrections, and then like move on.
But you won't have it like in this class.
I don't think it's gonna be in this classroom anymore. No.
Oh. At least they still have it though.
So for the people that like really care, and really want to get into like, did you end up doing practice tests last year?
Yeah.
Yes. Or like Matthew was doing them like in November-ish, right?
Kind of good part.
Well, I mean,
You don't know.
maybe you would have done worse than you have done. Like,
Well, yeah.
I don't want to look at it that way, but like, you don't know. this here. Okay, so again, I think the hardest part of this is graphically, where when we get into the algebra, it's just like a process. Like you just do this, 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 and you see this, and you do this. Like it's just a little more of like an algorithm procedure type thing. And so is the graph, but it's just trickier for most people. So this is. Oh, it's not. All right, I'm gonna switch. We're gonna go. I mislooked at something. Yeah, that's what I thought. All right, I'm gonna make my own graph. So, is there room on your note somewhere to? Is there? Perfect. So I'll probably make 2 or 3 graphs, and then ask you. You might want to like wait and see what I do, so you can like adjust your space accordingly. So this is f prime of x, and I'm going to ask you where f of x is increasing, where f of x is decreasing, and we can't see f of x. Where f of x has a relative max, and where f of x has a relative min. And we'll probably do a couple of these. So if you want to leave, like, don't make it take up the whole paper. I wish they gave a blank paper between like every section, like every other stuff. Although it's this thing.
Fat book.
Don't worry about the y values; they're not going to matter. And I suppose I should back up, and before we get into f prime, I think we're probably good here, but I could be wrong. But we did this a couple days ago, so if I give you something like that, and this is f of x, is that a relative max or relative min? It's relative max, right? Just like the top of the hill is a relative max. So that's a relative max, relative min, relative min. We're good there? That's fair? Okay. So the idea is, can we find those without seeing the original graph? So all I know is the derivative. All I know is like the rate of change. Can I go back and say like, well, where was this the biggest? Where was this the smallest? So I think it's helpful to kind of set up either on your graph or a number line. I'm gonna make a number line down here, and I'm gonna put on the number line every spot where I'm gonna put critical points. You know what? We can just make the same old box that we normally make. Yeah, no changes. So let's do the same box we did algebraically. We got x, we got the sine of f prime of x, and then we got, then down here we put like, is f of x increasing or decreasing? So the first thing we did was find critical points. Critical points are when the derivative, you tell me, when critical points are when the derivative of what? Equals 0 or doesn't exist. And there's not any doesn't exist on here because it's a nice smooth line. So where's the derivative 0? We have x equals -2. So we've got like some amount before that, and then -2. Where's the next time the derivative equals 0? That's 0, so I've got like an interval in between, and then 0, and then 2, right? So an interval in between, and then 2, and then actually another interval. We'll do one after this where I try to do it without this chart. It's definitely faster without the chart, but I think the chart will help you like kind of relay what we did yesterday with what we do today. So in my intervals here, this is negative infinity to negative 2 because it's like everything over there. And then between the next two is from negative 2 to 0, and then 0 to 2, and then 2 to infinity. So we're going to plug into the derivative. Yesterday we did it with an equation, so you're plugging into an actual equation, but I don't need an equation to plug in. If I said, what's the sign of f prime of x when x is like negative 3? This is f prime, right? So when x is negative 3, what is the sign of f prime of x? It's negative because we're below the axis, right? So what is f of x doing during that section? Decreasing. Excuse me. Hey, what's up? Yep. Thanks. Whenever there's a good moment. I would wait for you. Okay, at negative 2, what's the value of the derivative? So if I said, what's f prime of negative 2, what would you tell me? It's 0 because it's right on the axis. And then f of x is not increasing or decreasing, it's just flat. From negative 2 to 0, if I said, what's f prime of negative 1? That would be, we're above the axis, that's a positive number, right? So this is positive, so f of x is increasing. This is 0. From 0 to 2, what's f prime of x is? Negative. Why? Below the axis. So f of x is decreasing. If x is 2, f prime of 2 is 0. And then f prime of any of these numbers would be positive. So f of x is increasing. You can also like kind of shortcut this. Like I'm doing like the big long explanation, right? But you probably won't end up doing all of this for each of these. So maybe like the next level of like not showing as much work would just be go on the graph and just kind of, okay, we're below the axis here, so f of x is decreasing. Here, f of x is increasing because we're above the axis. Here, f of x is decreasing because the derivative is below the axis. Here, f of x is increasing because the derivative is above the axis. So this is just like a shortcut of that giant table, right? I'm totally over-explaining. I get that, but I'm going to like narrow it down as we go. So the increasing, decreasing, like we've answered. So where is f of x increasing? From 0 to 2, and from 2 to infinity. And then if you had to justify it, you would say, oh, yeah. Okay. So if you had to justify what I wrote, you would say that's not possible. So negative 2 to 0. Sorry, is that a bit more serious? Negative 2 to 0 and 2 to infinity. And if I had to justify it, it would be because f prime of x is positive. Where's f of x decreasing? Negative infinity to negative 2 and 0 to 2. If I had to justify it, it's because f prime of x is less than 0. So that's really what we did yesterday. Just kind of in a graphic form. Questions on that part? And I'm not saying like we did it yesterday, you should know it. Don't have questions. I'm saying like, are there questions there? Okay. So today is just adding like we're gonna take that information and use that to find where there's peaks and valleys on the original graph, or like relative maxes and relative mins on the original graph. So you can kind of start sketching the original graph. We don't know enough to like totally do it, but I do know that in this portion, the original graph is going down because f of x is decreasing. It's probably like a curve, but I don't know exactly, so I'm just making something that goes down. And then it's increasing up until I get to here. And then it's decreasing until I get to here. And then it's increasing. Did you see how I got that? So you get W. Yeah. So it's really probably like curvier and smoother. It looks more like that, but we get the same idea. So when the derivative switched from below the axis to above the axis, so the derivative switched from negative to positive, it means the original graph switched from decreasing to increasing. And that creates which one? A relative max or a relative min? It's a relative min because you got like a point that's lower. It's like the turnaround at the bottom, a point that's lower than every other point. So there is a relative min at x equals -2. And I'll justify it in a second, but there's another one, so I'm not going to do it yet. So where's the other one? At x equals 2, right? So, again, the derivative switched from negative to positive. It crossed through the axis, but from below to above. Which means the original switched from going down to going up, and then you get a relative min there. So your justification here, f prime of x switched from what to what? Be careful. What's true about f prime of x? What did f prime of x switch from there? The table of prime. Negative to positive. Decreasing to increasing is what the original did. So that's like what I said, be careful. So f prime of x switched from negative to positive. So from negative to positive. So then could you fill in the relative max and justify it? So where's your relative max? Be at x equals 0, right? And then your justification be f prime of x switches from pos to negative. So this, if I'm going back to this table, I can just kind of sketch out what's going on here too. Like this is decreasing, and then it's flat because we're at 0. This is increasing, and then it's flat. This is decreasing, and then that's flat, and then that's increasing. So you can look and say, okay, well that must be the bottom of a hill. This is like the top of a hill. This is the bottom of the hill. So that's my relative min, max, and min. So I'm kind of explaining like two different ways to think about it at the same time. Hoping that's helping and not hurting. But questions I can answer on that anywhere? Can I erase that, or are people still writing it? I can just go to like the next screen. So if you want me to go back to it, then. Alright, let's do another one. So this is again f prime of x.
They always start with that prime of x.
We can also, well, we could start with the original, but if I give you the original and say like, where's their relative max? That's like an advanced algebra problem, if it's even that, because then you're just looking at it like that. You know what I mean? But I can give you the second one also, which we're not quite there yet, but that is coming down the pipe. So I'm going to ask you where f of x is increasing, where f of x is decreasing, where f of x has a relative max, and where f of x has a relative min. And I'm going to give you a second to try it, and then I'll talk through. All you guys know we don't have school Monday. I just learned like last hour. Very exciting.
That was my smart thing for the day.
I think it was more my dumb thing. Either way you want to look at it.
Just look at it as my smart thing.
Yeah, that's stuff, yeah. Polo in right now, right?
No.
Or no, she's on the plane. We could have zoomed her into class. I'm sure she'd love to zoom calculus on the
I
phone.
don't know how long it takes to fly. Not Texas.
To Texas.
Carries like 3 hours.
We just flew to Cancun and it was 3.5.
That was it.
That's pretty close. It was weird. It was 4 on the way there and 3 on the way back.
Because her plane was supposed to
Yeah.
What? But the wind doesn't go north and south. That's what I was trying to
No,
figure
it's
out.
like the ocean. Flying away from the ocean. Like when I went to Seattle, it was an hour and a half longer going to Seattle than coming back. Because like the wind was off the ocean.
But that's like east and west. That makes sense to me. It was like straight south.
I know, but the wind off the ocean, I'm telling you. It blows it to the side. I was telling
But
you.
it would blow to the side both ways.
Yeah, so wouldn't it be the same both ways? That's what I.
It's going this way.
Google it,
Going
the
this
winds.
way.
Telling you. I'm telling you.
I mean, you're telling me, but you can't answer my question.
I
Google it.
think her plane left at 6, so I don't know.
This
She's
is
probably
number
like-
2 smart thing I said today. I'm up to 6 this year.
But it would be 11 o'clock.
Right, but it'd still be
It's
5
still-
hours
yeah,
later. She's like picking up her bag.
It says 3 hours and 3 minutes.
To get to Texas.
So she's
Yeah, and it was weird on the
Anyway,
way.
hi,
I didn't
Riley.
notice on the way back. On the way there, my watch changed time zones, and then like a half an hour later changed it back. So I think we flew into like I think we go like a little bit west and then came back.
Right. It's 6 hours English. I can't believe that Texas is that much farther.
Yeah, that surprised me. It took 6 hours to be. I feel like I flew to LA and it was like when I went to LA it was only like 5 or 6. You know helicopter. Okay. Sorry, I was like distracting people. Are we going to go through this or not? Not yet? Okay, I can wait. I'll shut up. I'm sorry. I like to get people working and start babbling. Yeah. You think you're all.
I still thought that was fine. One thing is fine.
She like already knows the purple homework.
Me too.
when she's bored, she doesn't know.
That's cool. Everybody's different, you know. It's kind of thing. Do you guys play like duos or do you creative and like battle each other?
We play Battle Royale, but it's a different group every time. It's me, Mike, and then whoever will join us. And it's really fun.
Like as solos or as
No, we'll do like
team up?
no, like we'll like go on Snapchat and just message a bunch of people until we get enough to run squads.
Okay.
So, but like it's a different squad every time.
Yeah, yeah.
Sometimes it's with Connor and Fournette. Other times it's Zach and Jaden. And it's fun.
Sometimes you message too many people and then it's like,
Yeah, then we end up getting like 8 people and we have to play creative or something. It's
Yeah, you be careful you don't invite too much.
yeah.
Okay. So, I think if I were doing this one, I probably wouldn't make that giant table. It's probably overkill. But like as you're getting used to it, maybe it's helpful. I would probably look at this and say f of x is increasing here. F of x is decreasing here. F of x is increasing here. F of x is decreasing here, and I know that because above the axis means the original is increasing, and below the axis means the original is decreasing. And then I could just write, okay, from negative infinity to negative 2. Is this the same one I did last time?
It's just
Well, at least I reversed it. Wait, is it reversed?
Yeah, it's just literally
the increase.
I did that way last time?
Yeah.
Okay.
You just take your answers and put them in.
If I had to justify it, the derivative is greater than 0. I'm decreasing from negative 2 to 0 to infinity. If you have to justify it, the derivative is less than 0. And then relative max, and you got options here. Like some people like to do this first, and then just kind of think through, okay, from negative infinity to 2, we were increasing, -2, and then at -2, we started decreasing. So if we went from increasing to decreasing, that makes a relative max. Some people look at the graph, and they're like, I know if I went from above to below, that's a relative max. Just kind of depends on how your brain works. And there's another relative max over here at x equals 2. The justification would be f prime of x switches from positive to negative. Relative min, just the opposite, so we get this at x equals 0, because the original graph goes from decreasing to increase. So this original graph would go something like that. I don't know the shapes like that, and it could be this. It could be like super flat and be like barely increasing, barely decreasing.
Hypothetically, could it be a circle?
Shut up.
I told you you're hitting one every day.
You said it was going to be like a smart question.
Could it be a circle?
No, it doesn't have a point.
Thank you, Bowman. You have to filter your questions through Bowman first. If Bowman agrees it's a smart question, you're allowed to ask me, otherwise you can't. Questions on that? How many had that? Is that alright? Okay, cool. Alright, let's do algebraically. So go back to right here. Let's go through how to do one of the problems. So, number 1, first derivative test, that's what this is called. You'll never have to know the name of it. But to find any relative extrema, so we're looking for relative max and relative mins. So just start thinking, like, if I want to know relative max and relative mins, what level do I have to be at? I have to be at the derivative level. Maybe that's not the best way to say it. But in calculus, if you want to know relative min and relative max, you're going to have to find the derivative. And where I'm like going to kind of compare that to is when you want to know concave up and concave down, you're going to want to know the second derivative, which we haven't gotten to yet, but I'm just trying to like separate them for you. So I'm going to first find critical points. So how do I find critical points? Derivative is at the top and bottom equal to 0. So y equals x squared minus 4 to the 2/3, which means y prime will equal 2/3 times x squared minus 4 to the negative 1/3 times 2x. Good, because we got to remember chain rule, right?
I remember the rule.
And then I'm going to make this into a fraction, so my 2/3 kind of already sets up my fraction for me. The 2x goes on top, and then this goes on the parenthesis thing goes on the bottom, and now your exponent is positive. Did you see the board shape? I couldn't write. And then, am I going too fast or is that okay? So now I take the top and bottom of that and set it equal to 0. If I take that and set it equal to 0, it's basically when does 4x equal 0, which happens at x equals 0. 0 matters. It definitely matters because we might switch there from positive to negative. Is 0 a critical point?
Yes.
How do we know?
Because it crosses the. Well,
Incorrect.
it gets to the x.
Let me just stop.
Well, okay.
Sorry, I appreciate you volunteering. How do I know 0 is a critical point?
Isn't it to do something with you can put it in there?
If I plug 0 back in here, am I going to get an actual number or am I going to get a number? I'm going to get a number. It looks kind of goofy at first because you get a -4, but you can take the cube root of a negative. It'll be a negative, and then you square it. And I don't even need to know what the number is. That is a critical point. So that's one of them. And even if it's not, I would still put it in my table. But I'm just identifying, is it a critical point or not? Then I'm going to set this bottom equal to 0. But remember, that's not nearly as hard as it looks. Because if you divide by 3, the 3 just cancels. If you raise both sides to the 3rd power, you're working with 0 over here. So like it's basically like impenetrable. Like you can't change it by dividing. You can add or subtract. But I can't like dividing by 3 is not going to change it. 3rd power is not going to change it. And then I would recommend factoring this, because if you don't, it's really easy to forget the positive and negative. As long as you remember the positive and negative, it's fine. It's just easier to do that if you factor. So I get x equals 2 and I get x equals negative 2. Are those critical points? So if I plugged 2 in here, I would get 0, right? Yeah. So what's the third root of 0? 0. What's 0 squared? 0. So those are fine. Those are critical points. So that's getting to there. Questions on getting to that point? Yeah. Not be a critical point would be, let's say my original function was like 3 over x minus 2. And I did all that stuff and I get down to x equals 2. Well, x equals 2, it's an important point, but it's not a critical point, because I did 0. Okay, so I make my table now. So we got x, I know I've got some numbers, and then negative 2, and then some numbers, and then 0, and then some numbers, and then 2, and then some numbers. And I'm going to put f prime of x sign here. I'm going to put what f of x is doing here. So if you build your intervals, negative infinity to negative 2, negative 2 to 0, 0 to 2 to infinity. I'm just going to like rewrite the derivative over here because I have to plug into it now. So if I want to know the sign of the derivative, which function should I plug into? The original or the derivative? I want to know the sign of the derivative. Should I plug into the original or the derivative, right? So that's my first job, is to find f prime of x sign. So pick a number from here and plug it into f prime of x. So if I plug in like negative 10, top would be negative or positive? Negative. The bottom, negative or positive? Positive. You'd get like 100 minus 4, some positive number. Cube root of positive number is still positive. So you get a negative divided by a positive, so that's negative. The original graph is decreasing at that spot, or in that region, not that spot. What about negative 2 to 0? So if I plug in like negative 1, the top is negative. The bottom, so you get like 1 minus 4 is a negative number. What's the cube root of a negative number? Still a negative number. Multiplied by 3, still a negative number. So negative divided by negative is a positive. We're actually increasing there. So then I can fill this out like a little more than I did a minute ago. What is the sign of f prime of x at negative 2? If I said what's f prime of negative 2, you would tell me hopefully 0. Like that's how we got that number in the first place, isn't it? Yeah, okay. And then here, I can actually like be a little more specific. This is the part I'm worried about. If I go from decreasing to increasing, what does that create? A relative mid. Because I'm going from going down to going up. So if I switch from decreasing to increasing, that creates a relative mid. I don't like this. I don't want to do this. Do you see what I'm doing? Finish that. Because it didn't come from setting the derivative equals 0, it came from setting the bottom of the derivative. It's not undefined. Well, it's like the derivative is undefined. Yeah, the derivative is undefined. That's fine. Yeah. So really, this would be technically correct, but I feel like that's adding confusion rather finish that chart. Try to tell me where those relative maxes and mins. Also realize again, I'm way over detailed explaining this. These don't take as long. I'm not making them. We've done like 3 problems the whole hour, right? Like it's not that bad. I'm just making sure I'm explaining overly thoroughly.
I just think it's funny when he starts teaching. It's
It's so annoying because then I can't hear you, and then like I get wrong information. Oh man, I got that one wrong. I should have known that.
or he reads it out loud.
That's what I was saying. He's like,
Oh my god, he does math.
like the opposite
So
of headphones.
I
Not
can
you, like, you know, headphones in, so also he needs like something to speak into. That would
What are
go
those
into,
things
like
you
like a
used to
speaker.
Oh
that
my
goes
god,
right
the
into-
PC
PVC pipes you used to read into it and it would go to your ear.
Or get a candle string.
We used them in elementary school. It was a PVC pipe and you would like read into it and then you could hear yourself reading.
Do other people hear it?
yes.
Well, yeah,
Well,
but
you
you're
started
whispering,
whispering.
it like goes up because you're trying to learn that
Or
sound.
I just
It's
get
like
so
an
worried.
auditory process.
You know those little like cups that go up your mouth for singers? So that you don't whisper. Like it's not like a fucking friendly thing.
I did not know.
Yeah, so like you can like yell into it and it'll muffle it.
Really?
Yeah, because it's for people that are like opera singers.
We should get him a little soundproof that
Why would
like
I?
box for his.
With a window.
Okay.
But we can only open like
One of those mailboxes.
At 0, I could actually say the sign of the derivative is 0 because I got that by setting the top of the fraction equal to 0. From 0 to 2, I can't fill this in yet, relative max or relative min, because I don't know what's happening after. So from 0 to 2, I've got to check that. So the top would be positive, the bottom would still be negative. So this would be negative and therefore decreasing, which creates a relative. If I switch from increasing to decreasing, relative max. At 2, what's true about the derivative at 2? Is it 0 or undefined? It's undefined, and I know that because did I get the 2 from setting the top equal to 0 or the bottom equal to 0? I got the 2 from setting the bottom equal to 0. If the bottom equals 0, like if you're dividing by 0, that's undefined. So that would be this. I don't really ever see them ask about that. Like I wouldn't worry too much about these 2 things, but I just wanted to be like accurate. And then from 2 to infinity, well, if I plug in like 5, the top is positive and the bottom will be positive also. So that's increasing, and then we switched from deep to ink. So that's a relative min. Questions on that table? Because what I'm about to tell you is pretty annoying. So let's make sure there's no questions before I annoy you. Questions on what I'm doing, like how I'm finding, like we basically got our, here's the annoying thing. We basically got our answer. There's a relative min at -2. There's a relative max at 0. And there's a relative min at 2. The AP test does not, and so that I won't either, accept that chart as justification. Which is, like, it drives me crazy. We just spent 10 minutes making that freaking thing. It shows everything you could want, but they're like, no, that's just like your scratch work. You have to justify it. I just didn't. It's not up to me, but so you've got to actually go through and do what we did before and say there's relative min at x equals -2 and x equals 2. And then if you have to justify it, f prime of x switches. And the chart is helpful, right? So if I'm at -2, the derivative switched from like before -2 it was negative, and after -2 was positive. So f prime of x switches from negative to positive. It's like you have to write the whole chart and then like write a paper about it. It seems a little unnecessary, but they didn't ask me what I thought. So there's a relative max at x equals 0, and that's because f prime of x switches type of thing for like the next month and a half. I don't know, month, as long as we're doing derivatives, you'll be using this in some form. Because when we do the second derivative to find concavity, it's the exact same process. You're just using the second derivative instead of the first derivative. So like, this process is very important, so I want to make sure I'm very thorough about it and hopefully get it unlocked. Any questions on that one there?
On the test, would we be able to write pause tag?
Yeah.
Tag
Yep. Yep. Cool, fancy nerdy abbreviations.
Similar to that, so you said Afflevax switches from.
No. You can't see FLX, so how can you say that? That's what they would say. Another way I could say that in this one, I told you to use the first derivative test, Matthew. Why you tell me about the, like that? Yeah, they want you to use the derivative to justify. Other question. That was a very good question.
But it said
I
derivative right there. So you have to run it by me next time.
I'm gonna say I'll just give you all tomorrow to work on. What are we on? 5-4. So I'll just give you tomorrow to work on. I would do like 1 or 2 of them tonight, just to like make sure like we just did it. Like keep it fresh in your brain, get a couple reps in. But I'm not gonna do a new lesson tomorrow. I'll give you time to work on it. We'll go over any questions you have, and we'll move forward on Tuesday. We're at school.
Riley said she doesn't know when she plays because teams are dropping out.
But she is.
Oh, the airports are like a mess. Though.
Yeah, I think they grounded